Today's lab is to synthesize N-Phenylphthalimide. So we're making an imide compound from aniline and phthalic anhydride. Okay, so phthalic anhydride and aniline. We will be using the acetic acid as a solvent. Okay, and we reflux for 30 minutes and we got a nice product. So first, using the balance, get 1 gram of phthalic anhydride. Okay, so can you see it? Using weighing papers, make it 0. And add 1 gram of phthalic anhydride. And when you transfer, make sure the bottle is above the papers so it don't spill on the floor. So 1 gram of phthalic anhydride will be added to the long water flask. Okay, so tight it. When you transfer the chemical into a flask, don't do it over the heating mantle, because if you spill it, they're burning on the inside the heating mantle. So when you're adding it, try it away from it. And when you add the solid from the weighing papers, just make a cone shape. Okay, this, and put it in. And make sure all of them completely transfer. Okay, we need the 15 milliliter of acetic acid as a solvent, but since we have the aniline as a reactant, so we will transfer 5 ml of acetic acid first. Okay, 1/3, because we're using the last to rinse the aniline completely. Okay, first add 5 ml of acetic acid. Add 1 milliliters. And then add 1 milliliter of aniline. So since I add 1 milliliters of acetic acid here, so I need 1 more. So I add up to 2. Okay. The reason adding aniline after 1 ml of the acetic acid is because this grade cylinder already has acetic acid inside. So if you add 1 milliliters, actually you add less than 1. So I have a 1 ml of acetic acid and 1 ml of aniline. So I can add 1. So there are total 60 milliliter of acetic acid. 1 milliliter of aniline. So all I have to do is add 9 more milliliters. So when I add this one, the aniline remaining in the gray cylinder will be completely transferred. Okay. So 9. Okay, so everything is added away from the heating mantle, so there's no chance you spill it inside the heating mantle. And don't forget to put the boiling chips for homogeneous boiling or prevent the superheated. Maybe a 2 or 3 pieces, okay. And adjust. Okay, position it. Make sure the flask touch the heating mantles. And tight. And tight. Okay. And the reflux, I've attached condensers. Okay, reflux condenser. So with the grease, as I said, we don't need a lot of grease because it's headache. Just a little bit to the 3 different places. And put it there and spinning. Make sure the grease is spreading. Okay. And then nothing else, make it straight. Okay, so this one, you don't need to tight, but just make sure it's holding it, okay? Just prevent this falling down. Okay, straight up. Now, we need cold water in and out. One on the top, one at the bottom. And remember, water going in from the lower place and off to higher place. If you go reverse, for example, you put the water in from the higher place, okay, see what happens. See, there's no water there, okay? So, water should go in from the lower and out to higher place. Slowly open the water. So, see the water filling from the bottom and up. And water doesn't need to be go fast. Just flowing of water is fine. See? Okay, so reflux is set. Now we have the heating. Okay, so turn it on. And reflux for 30 minutes doesn't mean when you turn it on and waiting 30 minutes. Reflux 30 minutes means when the solution is boiling and you start counting 30 minutes from that moment. So just wait. And as you know, the benefit, there's a benefit of the reflux. Reflux reaction temperature is close to the boiling point of your solvent. Today is acetic acid, so it's about 110 degrees Celsius. And also, even though it's open on the top, solvent is not removed from the reaction flask because when they vaporize, because of the cold water, they are condensed and falling down. So, making vapor, moving up, and condensed and be turned into the liquid and falling down. So it's up, down, up, down. So it's called reflux. Okay. So you can control the temperature depending on which solvent you are using. Especially when a side product is a gas, then gas can escape. The reaction shifting to the product side because there's equilibrium. So reaction going faster. So there are many benefits of the reflux. Okay, it's still refluxing and it's already 30 minutes past. So we'll turn it off and wait until it's cooled down. But the water should be on. Okay, don't turn off the water. And to make cooling faster, we're lowering the heating source, which is the heating venters. So we remove this one. And stay this down. And we are waiting until it's cooled down. And meanwhile, it's off. Okay, just waiting. And next, we will put in ice bath. So precipitate more product, which is imide compound, and then do the vacuum filtration and do the recrystallization in ethanol. Vacuum filtration you already did before, but need a Buchner furnace and suction flask. This is combination. And while we are waiting, I'll show you how to set up. Okay, first, this suction flask very easily off because of the water tubes, so it's better to be secure using the link clamp. Okay, so it's not falling down. And connect it. And this one will go to, oh, you don't see it. Side of the water. And then put this Buchner funnel on top of it, and make sure this adapter is not all the way going in, because once the vacuum is applied, this is going inside, it's not possible to take it out. So about halfway, no more than 2/3 go inside the flask. Okay, let's see. Still hot, so we have to wait. Okay, as it cool down, you see the white solid inside forming. Maybe some of them is a product, and also remember the melting point of acetic acid is about 5 degrees Celsius. So at this temperature, maybe they are also crystallized. So, okay, that's cool enough. Then slowly remove and put into ice bath. So for the cooling, and maybe acetic acid also. Okay. Keep it there for a while. So most of the products, maybe at this point is crude products, is precipitate or sometimes crystallized inside the solution, and then we will do the vacuum filtration. And also remember one more time, acetic acid, melting point of acetic acid is about 5 degrees Celsius. So in ice bath, which is 0 degrees Celsius, so the acetic acid also frozen. So crude product solidified, and also the acetic acid also solidified. Okay. So before your filtration, you have to swirling it, just to make sure acetic acid is not filtered. Okay, I think this is okay, cool enough. Now, turn it off, the water. Gently remove the condenser. Okay, cold enough. Okay, let's forward, just keep it warm. Meantime, prepare the hot first. Okay. So, Connect the water tube, one to the side, one to the side of the water tap. So when you turn it on, water moving down, and it's sucking the air from the side together, which is connected to the vacuum, the plug. So open all the way in. Yes. Can you hear the sound? It's on the vacuum. Okay. Then connect the open openers. Make sure its pressure is high. Yeah. Yeah, it's so high. You can hold it. Okay, so vacuum is good enough. And different from gravity filtration, vacuum filtration needs the feeding size of the hook opener. So this filter paper size, diameter, and your hook opener should be matched. You cannot use the bigger one, you cannot use the smaller one. Okay? So put it there. So it's the feeding size. And now the paper and the hook opener, there's a gap. So when you pour in the solution, the solid can go between the papers and the hook opener, so you're losing your product. So we have to wet the paper. Okay? So yeah. Just a little bit of water. Okay. So now the paper is wet, so they're stuck on the hook opener, so there's no space between. So no solid may be escaping between those two gaps. And also make sure the water is max all the way. Okay, so swirling it a little bit. And maybe you have a tendency to transfer this solution with the solid slowly. But if you transfer slow, most of the solid remaining inside the flask. So you have to go quick but gentle, so no splash. So swirling it. And quick and gentle, transfer all over them. Okay. Okay, so this is almost no solid inside. Okay. If there's a solid remaining, maybe you can use the cold acetic acid or cold ethanol to rinse a little bit. But looks like you don't need it. It's completely transferred. Okay. So we got the white crude product. And now we transfer this to aluminum flask to recrystallize in ethanol. Okay. When you finish the vacuum filtration, don't turn off the water. If you turn off the water, since the flask is on the vacuum, water going back flowing into the flask. Today it is okay because our product is a solid, not a liquid. But it's better to have a habit. Don't turn off. Wake the vacuum first, and then turn it off. That's the correct way. Okay. Okay. Now transfer all the liquids, all the solid waste paper. Okay. So transfer the solid, but if you transfer the solid directly to the flask, maybe you're losing it, because it's not easy to completely transfer the solid from cooker pot. So what you have to do is tapping. If it's lucky, everything fall down. Yeah, most of them is out. So if it's still remaining there, it's not coming out after tapping, then you scratch just outside. Okay, just outside. The purpose is to take the whole paper out like this, so it's nothing is there. Okay, it's clean. and then you're holding it. Just scratch using the side of the spatula. Now all the solid is transferred, and then transfer into aluminum. Okay, as I showed at the beginning, you can use the cone, make a cone, and move it. This is the difference. Okay. Okay, all the solid transfer into flask. Okay, and today's the solvent is ethanol. So maybe we're using about 60 milliliters of ethanol, but since we have to make the saturated solution at high temperature, boiling point of the solvent, we add about 50 first. So remaining about 10 here from the 60. So about 50 milliliters of ethanol is added. Switch. And our hot water is ready. It's a good habit to prepare the next step material ahead so we can save time. Okay, put it inside. And wait until it's boiling. And ethanol is flammable, so you cannot heat the ethanol directly on hot plate, because the ethanol vapors touch the hot plate, which is hot, it makes fires. Okay, so whenever you're heating the organic solvents or flammable solvents, using the hot water, so indirectly heating. Only water you can heat directly on hot plate. Okay, still this is solid. Since the 50 milliliters is not enough, so add 10 more milliliters, so up to 60 milliliters of ethanol is added, and all the solid dissolved. So now it's cooling to room temperature. Okay, so slowly cooling it. And we don't need the hot water best. Move to the side. And waiting until it's crystallized. Okay, it's crystallized at room temperature, so to precipitate more, we cool it in ice bath. So more imide compound will be crystallized. When the solid is crystallized, the purity is increased. So it's one of the good way to purify solid products to pure form is recrystallization. And while we are waiting, we connect the water tube to the side and to the side of the water tap. Don't connect this to the bottom of the water tap, because if you do it, sometimes people make a mistake. Water going in, not make a vacuum inside the flask. Okay, filling the flask with water. So think about to the side. When the water is on, water down, and air from the side also sucking together. So the flask becomes vacuum, under the vacuum. So vacuum is much stronger to pulling than the gravity. Okay, so cold enough. Once again, the filter paper is one size which is fitting to the book openers, and because it's dry, there's a gap. It's easily open. So we have to wet the paper with a solvent. Maybe you can use the ethanol. So turn on the water all the way and wet the paper with a solvent. Okay. And cold enough. Remember, rolling it, quick and gentle transfer. How much is only remaining behind? Nothing. Okay. So if you transfer slow, a lot of solid remaining inside the flask. So you have to add another solvent and transfer. So maybe during the process you will losing your product. So remember, rolling it, just take out from the ice bed, rolling it, quick and gentle. Don't you go too quick. If you go too quick, just splash. So you're losing your product. So gentle but quick. Okay. Okay. Nothing falling down. Bench, because we don't want the paper to wet. Okay, when it's done, what you have to do? Turn off the water? No. Break the vacuum first. And then turn off the water. Okay. Okay, this is the purified final product. And let's tapping first. Wow. This time we are lucky. All the solid, including the papers, is fall down. There's nothing inside. That's good. And then holding the papers, scratch. Okay, all the solid transfer. And ethanol is easy to dry, so assuming this is dry, because we leave it under the vacuum for like a minute. So. Okay, then go to the balance. Okay, where's the balance? Go to the balance. The wing paper, make it 0. Now we transfer. We got 0.94 grams. This can move it, but just pick up the number which is staying longest. So let's say 0.93. Okay. So we got 0.93 gram of imide compound, which is white solid. Okay. What you have to do next? Clean up. Bye.